Hi, this is a demonstration of Global Communication Technology's Talk Permit Tone Detection feature. This feature allows us to offer a dynamic transmit delay with trunked radios. The basic problem that this solves is that when you key up a trunked radio, it needs to acquire a channel to talk on. When it does that, it plays a talk permit tone. And if it doesn't get a channel, then it plays out a failure tone. And these tones allow users to know when it's okay to speak. But with that in mind, audio patching systems like Globals usually offer what's commonly called a transmit delay. This basically keys up the radio when it has audio to send to it, and at the same time it buffers up audio. Once the transmit delay period expires, the audio plays out to the radio. And that delay is supposed to give the radio time to acquire a channel. But there are two problems with this approach. First, the channel acquisition time is indeterminate. It could take 1 second or it could take 5 seconds. Usually it's pretty short, but since it can be long, you usually have to configure the transmit delay feature for the longest realistic time, or you end up cutting off the beginning of the audio. And configuring it for that long time adds a lot of unnecessary latency, which is really not good. The second problem that our feature solves is that channel acquisition could fail, right? And you get the failure tone. And when that happens, the patching system doesn't know it. So after the transmit delay expires, the audio eventually just gets sent out to the radio anyway. But that audio will never be heard because it doesn't have a channel to talk on, and that's a really bad thing. So to deal with those problems, Global has developed some algorithms to detect the talk permit tone, and that detection allows us to either shortcut the transmit delay and play out the audio as soon as we have a channel, or if we get a failure tone instead, we can rekey the radio and try again. But to add complexity, since talk permit tones can sound different on different radios, we added some algorithms to learn from the radio what the talk permit tone sounds like, and then we use that to create a pattern for that specific radio, and then that pattern gets used to do the tone detection in real time. So that's the feature that I'm going to show you, all of this stuff. We don't have a trunk radio system lying around, so our setup here is basically simulation. We have a radio module in one of our units connected to a Baofeng radio that can play out 5-digit DTMF S codes at the beginning of any transmission. So when we key up the radio, it'll play out these tones. And we're going to use those tones to simulate a talk permit tone coming from a radio. We also have another radio on the same frequency, so you can hear the audio like somebody out in the field would. That radio is not in the video, but you'll hear it. Unfortunately, you'll also hear those S-code tones in that audio because our simulated radio is playing them out over the air. But you wouldn't normally hear that on an actual trunked radio system, so just use your imagination. Okay, so we have one of our G4-way intercommunication systems with several modules in it, and I'm going to patch a radio and a handset together in the UI here. So you can see that here. Any audio coming from the handset will be sent to the radio and vice versa. So also to start us off, this radio module is configured with a standard 6-second transmit delay, a fixed delay. When I key up and speak into the handset, because it's patched to the radio module, it will go ahead and key up the radio right away, and our simulated radio will play out those simulated talk permit tones. But the audio from the handset won't be sent to the radio until 6 seconds later, because that's what I have the fixed transmit delay configured for. So let me just show you the kind of the standard behavior. So I'm going to key up the handset. Hello, 1, 2, 3.
Hello, 1, 2, 3.
You see how my voice was delayed by 6 seconds? That's a typical transmit delay. And that latency is one of the problems we're trying to solve. Okay, so let me now show you our detection feature. So first thing I need to do is train the system to listen for the talk permit tone for our specific radio. Fortunately, this is really easy to do from the operator's perspective. He just clicks on this TX delay training button, and he clicks on the module that he wants to train. In this case, it'll be the radio. So I'm going to do that. Training can take a few seconds. The system will try to acquire a channel 2 or 3 times so it can get a good pattern. It looks like it did it in 2 that time. Okay, so now the radio is trained. The system is trained, and you only have to do that training one time. The pattern is saved on the system, so it'll be there the next time you turn it on, and you're good to go, unless you want to hook up a different radio or something like that. Okay, so now let me key up the handset again, and this time the system should, once it hears the talk permit tones, it should shortcut the transmit delay and play out the audio right away instead of after 6 seconds. So I'm gonna key up the handset and just listen. Hello, 1, 2, 3. So you see that? You got a little bit of echo there because I'm right next to the my microphone is right next to the radio. But this time the audio came out right after the talk permit tone sounded instead of 6 seconds later. So that means the system correctly matched the pattern and it shortcut the transmit delay, which is fantastic. Okay, so now what I'm going to do is I'm going to have my colleague change the S code on our fake trunked radio to simulate a failure. So it's a different tone, so the system will assume that it's a failure. While he does that, I'll just give you a quick explanation of what you'll see and hear. I'm going to speak in the handset again, but this time the system won't detect the talk permit tone because it'll sound different. Instead, it will assume it was a channel acquisition failure tone. So what it'll do is it'll try to rekey the radio and get a channel that way. To see if it can do it after 1 or more additional tries. Just as a side note, because of the way we're simulating, you'll still hear the tones come out of our second radio, but in the real world you wouldn't have that. And also, after 6 seconds, the system will give up trying to acquire a channel, just like and play out the audio just like a normal transmit delay. And you can change that 6 seconds to whatever you want. We can go up to 10 seconds, but we're just using 6 seconds right now for this demo. And again, because of the way we're simulating, you'll hear my voice come out the second radio, after 6 seconds, but in the real world you wouldn't, because the radio wouldn't actually have a channel to talk on. So just, again, use your imagination. Okay, it looks like he's long since got that new S code set, so let's give this a try. All right, I'm going to key up the handset again. Hello, 1, 2, 3. So you see that? This time the system tried multiple times to get a channel before giving up. You heard those S tones in the audio there, or S codes in the audio. And after 6 seconds, the system just played out the audio that it had buffered up. It never thinks it got a channel, so it just treated the transmit delay like it was a normal transmit delay, and played out the audio. So that about covers it. If you'd like a more in-depth demo or want to learn more about Global's products, just head to our website or send us an email. Thanks for watching.